Okay, so we're going to do the next type of single replacement reaction, and this is going to be metal plus an acid. But first, we need to talk about some things. In the first type of single replacement reaction, we take a metal, like copper, and we put an ionic compound solution with silver nitrate. And what happened was the metals swapped each other. So the copper went into the solution and the silver came out of solution, or the copper joined forces with the nitrate and the silver left. Okay. Uh, and the first thing we had to do before we even started this, we had to take the silver nitrate and dissolve it in the water. So let's talk about this. Why did the silver nitrate water? Well, when you put an ionic compound is put in water, water has the ability to pull apart the ions. So if you take sodium chloride and put it in water, water has the ability of breaking apart the Na plus from the Cl minus, and we'll go over this at the end of the semester. Okay, so this all ionic compounds within this, not just sodium chloride, silver nitrate, every single ionic compound we talk about. And that's how we've done the single replacement reactions. We take the ionic compound and we put it in water and then dissolve it, and then we add the metal. So, um, covalent compounds don't do this. At least they don't split apart in water. They can dissolve in water, like when you put sugar or glucose in water, it dissolves. But the reason why it dissolves is for another reason. So, um, so covalent compounds, when they dissolve in water, if they do, is because they not because they split apart. It's for another reason. So, anyways, so let's take a look at acids. Acids, first of all, are covalent compounds. So that means is that if they dissolve in water, it's not because they split apart, okay? Because that's what covalent compounds do, or don't do. But actually, ionic compounds do split apart. And they do it for the same reason ionic compounds do it. So water breaks acids apart just like it does ionic compounds. So if you take hydrochloric acid, HCl, and put it in water, what happens is the water will break the HCl into H plus and Cl minus. Okay, so one of the things what I like to say, is an ionic compound is a covalent compound that behaves like an ionic compound when you put it in water. Okay, so acid is a covalent compound that behaves like an ionic compound when you put it in water. What does that mean? It splits apart into a positive and negative ion. So same thing happens with phosphoric acid. When you put phosphoric acid in water, what happens is 3H's pop off, 3H plus pop off, and a phosphate pops off. Okay? Right. So notice you have it's sort of like if you had sodium phosphate. It's a tertiary ion compound. You put this in water, what's going to happen is that three NAs are going to pop off and the phosphate is going to pop off. So you're going to end up with three NAs and phosphate. Okay. So in a sense, the hydrogen is behaving like a metal. Okay, so that's what I just said. In fact, a good definition of an acid is when you put it in water, it gives off an H plus. And notice that the H kind of acts like an acid I just said. So say if Na plus Cl minus turns into Na plus Cl minus, and put HCl in the water, H plus Cl minus. And it just, like I just said, this is that phosphoric acid gives off 3 H pluses. And you remember, one way to figure out the formula of a tertiary acid is take the phosphate, PO4 3 minus, okay, and then how many hydrogens it has is the same as the charge, 3. Okay, the reason why is because those 3 H's are associated with that 3 minus. And finally, we can name an acid as an ionic compound. So, and we could treat hydrogen as metal. So hydrochloric acid can be called hydrogen chloride, and the chemical formula can be H plus Cl minus. Just like you treat it as though it's an element from the first column. So Na plus Cl minus. So hydrogen now, when it's an acid, is treated as though it always has a +1 charge. Phosphoric acid is H plus 3 PO4 3 minus. And the real reason why it has 3 is because you have 3 crisscross charges. And its ionic name would be hydrogen, because it's hydrogen phosphate. We would be using both the acid and the ionic names in the formulas, okay? So be able to change acid to ionic in terms of the names and formulas. Okay, so let's use an acid instead of an ionic compound, a single replacement, because we said acid can act just like an ionic compound. And what we're going to do is we're going to take zinc metal and add it to hydrochloric acid instead of ionic compound. Okay, when this reaction takes place, let's talk about it actually taking place. What you get is a lot of bubbling, kind of here's a picture of it, and vapor. So here's the zinc, and it's placed into hydrochloric acid, and you get all this bubbling, all right? So what's going on here? Well, the bubbling is caused by gas being released in this reaction. Notice also that there is not another metal being formed. So you're not, so this guy isn't turning into copper or anything like that. But what you're doing is you're getting a gas. So what's happening here is the metal is actually turning into a gas. And so you got a solid, in a sense, turning into a gas. Right, so the word equation would be zinc metal, or you could just say zinc, plus hydrochloric acid forms zinc chloride and hydrogen gas, and we'll see how we got that in a second. And so you have zinc, HCl, zinc chloride, and H2. Notice that now, like here, zinc is Zn0, hydrogen is H2 0. It's not H2O, it's not water. Okay, so let's look at the naming a little bit. So we have zinc metal plus hydrochloric acid gives me zinc chloride and hydrogen gas. How do we come up with these over here? Well, what you do is you change the acid to its ionic name, hydrogen chloride. And then what you do is you swap the zinc and the hydrogen swap places, just like in the other single replacement reaction. So what the zinc goes to the chloride, so zinc chloride, and the hydrogen comes out. So you get zinc, chloride, and hydrogen. In terms of the chemical equation, it's zinc, hydrochloric acid, or hydrogen chloride, zinc chloride, and hydrogen. Remember that zinc chloride is zinc is ZnCl minus Zn2 plus Cl SCl minus, so put a 2 there, and so you get that. Okay, as far as balanced equation, start with negative ion, so you need 2 chlorines. First step is get 2 chlorines, so put a 2 there. Okay, now check your hydrogens. Second step, you need 2 hydrogens, and you're okay. And then you can see that you have, right, and there you go. All right, so that's it. And notice that the zinc has gone from no charge to 2 plus charge, so it lost electrons, so it's oxidized. Again, hydrogen, and so forth. Okay, so let's do another one. So aluminum plus sulfuric acid. So we're going to write the word equation, the initial balance equation, balance it if necessary, and what gets oxidized and reduced. And this will be a little tricky. The first thing I like to do, like I said, is I change the ionic acid to its ionic name. So sulfuric acid will become hydrogen sulfate. The tertiary acid, remember, is hydrogen plus ionic polyatomic ion. So this is what I have. I have aluminum plus hydrogen sulfate, and they swap places, so you end up with hydrogen plus aluminum sulfate. Notice that all the names stay the same. They just change places. All right. Okay, next thing. So this is, you write the initial chemical reaction. So this is sulfuric acid, H2SO4, and aluminum sulfate is Al, 3 plus. Sulfate is SO4, 2 minus. Okay. Put a 2 here, crisscross charges, and you get Al2SO4, 3. So we're going to balance the sulfate first, the negative ion. So I have 3 over here. So what I'm going to do is I'm going to put a 3 here. Right, next thing I'm going to do is I'm going to fix the hydrogens. I have 3 times 2, which is 6. And so I need to have 3 times 2 here is 6. Okay, and then I count my aluminums. I have 2 over here, so I need to put a 2 here, and I'm done. Okay, so let's go over again how I do this. Okay, what I want to do is balance negative ion first. I have 3 sulfates over here, so I'm going to put a 3 over here. I don't care about the hydrogen yet. So 3, I need 3 sulfates. Okay, so I put a 3 over here. Okay, that's a 3. Okay, next thing I do is I fix my hydrogens. So now I have 6 hydrogens. So I need to put a 3 here. 3 times 2 is 6. Then finally I have 4. So the third step I have 2 ALs. So the third step is I have 2 ALs over here. And I go put a 2. I'm done. Right, so you notice what I do is I start off one piece, okay, and go fix it, and then what I do is I fix the piece that's attached to, okay, and then I come, and again, here's, you see what's going on. So you have the aluminum is losing electrons, oxidized, the hydrogen is gaining electrons, and you know there isn't a 2 over here, but it doesn't matter. Just look at the hydrogen. Hydrogen goes from plus to 0, and don't worry about numbers. It's just the charge. So it goes 0 to plus, your plus to 0. So this becomes more negative, become by less positive, so it gets reduced. Okay, so that finishes the acid single replacements. What we're going to do now is go to the last type of reaction, double replacement. Okay.